Hello everyone, welcome back to my YouTube channel. This is Sahana LK from the 4th SEM Tejas section from the Department of Electronics and Communication. Today I am here to present the subject of Principles of Communication. In that, I chosen a topic of Frequency Division Multiplexing. Here we have an animation video for the Frequency Division Multiplexing. Yes, we have a multiplexer and the demultiplexer. A signal is generated and modulated by sending a device and it is carried over the separated bands. The modulated signals are combined using a multiplexer and transmitted over the communication channels. We are having a channel 1, channel 2 and the channel 3 which are having a frequencies. And at the receiver end, the combined signals goes through a demultiplexer to extract the individual signals. We can see here. Let us discuss what is a frequency division multiplexing. In frequency division multiplexing, multiple signals are combined for transmission on a single communications line or channel with each signal assigned to a different frequencies within a main channel. Let us discuss the multiplexer and demultiplexer in the FTM. It is a two-way communication circuit requires a multiplexer and demultiplexer at either end. Multiplexing is used when frequencies of lower bandwidth are transmitted through a channel with a higher bandwidth. Here, consider a long-distance cable with a bandwidth of 3 MHz. In theory, it should be possible to place and transmit 1,000 signals, each 3 kHz wide in the channel. The circuit that does this is a multiplexer. It accepts input from each individual users and generates a signals on a different frequencies for each input. This results in a signal on high bandwidth and it has a single containing data from all the users. Let us go through examples for the FDM. Consider for a frequency bands, each with a now finite bandwidth of 150 kHz and separated by 3 guard bands of 10 kHz each. To accommodate all the bands, the communication channel should have the capacity. Here, we can multiply the 150 into 4, which we having a 4 finite bandwidth, and plus, which we have a 3 guard bands, that into multiple 10, which we will get the answer of 360 kHz. The FDM multiplexes the 4 frequency bands and sends them via the communication channel. Each message modulates a different carrier, so the modulated signals are in different frequencies bands that do not interfere with each other. Let us discuss the advantages and disadvantages of FDM. When FDM is used in a communication network, each input signal is sent and received at the maximum speed at all times. However, if many signals are sent along a single long distance line, larger bandwidth is required to ensure a proper system performance. Here, let us discuss some two disadvantages. First, since the various frequency bands must be separated by guard bands, there can be a bandwidth wastage. Second, if there are significant non-linearities in the transmission link, there could be crosstalk among the different signals, resulting in communication. It will get the errors. This is a communication problem in FDM because it uses analog signals, which are more prone to noise disruptions than digital signals. Here, let us discuss some applications of FDM. These are used in the radio transmission, which are commercially amplitude modulations and in the frequency modulations, and also used in the TV transmissions and the wireless networks and the satellite communications and in the cellular networks. Thank you.